Hello and welcome. Today we're going to be looking at how we can represent a situation using a table, a graph, and an equation. You'll remember from last class we talked about this equation y equals mx plus b. And we used it to write an equation to represent a situation. So in this example, we have an example with Miss McKibben. So it says, Miss McKibben is ordering t-shirts for the 8th grade promotion. She talks to the designer and they charge $20 to design the shirt and $5 for each shirt you order. So we're going to need to write an equation. We still use the same formula, y equals mx plus b. And we're going to think about what's the thing that can change. So I figure out what can change in this situation is the shirts that I order. So I'm going to put X is the shirts. And each shirt costs $5. So I have 5X because it's $5 per shirt. Then what do we have to start by paying? Well, they charge $20 to design the shirt. So no matter what, I'm going to have to pay them $20 to design my shirt. In this case, we don't know how much we're going to have to pay. We won't know that until we know how many shirts we order. So we're going to keep it y equals, and we have y equals 5x plus 20. Y represents the cost, and X represents the shirts. And we can use this to find the cost of any number of shirts by filling out this table. When we're doing this, what we're going to do is use an equation that looks like this. Y equals 5 parentheses plus 20. The reason I put in the parentheses is this is going to allow us to plug in or substitute any number we want for X. Notice that I wrote the equation exactly the same, and I just left a spot so I can put a number for how many shirts we want to order. On my table, I'm going to plug in my X and my Y value. The way that I figure out which one is X is by which one can change. So can I control how many shirts I order or the cost? The only way for me to change the cost is to change the number of shirts that I order. So the one that I can change is the shirts. You might have heard this in science as the dependent and the independent variable. It's the same thing in math. And then Y is the cost. This is the dependent variable because the cost depends on how many shirts I want to order. Now let's look at how we can actually figure out the cost. So we have this equation where I put in a space to represent the X. What I'm going to do is I'm going to plug in these different values. So where my X was, I'm going to put a 0. And let's see what we get. Well, 5 times 0 is 0. And 0 plus 20 equals 20. So for 0 shirts, I have to pay $20 because I still have to pay them to design the shirt, even if I don't order any shirts. Now, we can use the same equation that we have, but where the X was, now we're going to put 1. So what if I order 1 shirt? Well, $5 per shirt times 1 shirt is $5 plus 20 is 25. Okay. What if I want to order 2 shirts? Well, where the X was, that represents shirts, I'm going to put 2. 5 times 2 is 10, plus 20 is 30. At this point, you might be noticing a pattern that it goes, starts at 20 and then plus 5, plus 5. So then 3 shirts would be 35. 4 shirts would be 40. And 5 shirts would be 45. But what about this one? It goes from 5 to 10. So we're skipping numbers. You might be able to figure out, well, 6 shirts would be 50, 7 shirts would be 55. But a quicker way is you can go back to using your equation. So if I want to order 10 shirts, I would put 10 in for my X value. 5 times 10 is 50. So I'm going to have to pay $50 for the shirts plus the $20 printing fee. So I would have to pay $70 in all. And then you'll notice we skip some numbers again. And now we're looking at what if we get 20 shirts? We can do that also. We put 20 in for X. 5 times 20 is 100. Plus our $20 design fee. We have to pay a total of $120. So now we've found the cost for all of these different numbers of shirts. But we want to see what would that look like on a graph. What would that look like on a graph? So we have this graph, and we're going to start by labeling our axis. You'll remember from an earlier unit, the x-axis goes from left to right, and the y-axis goes up and down. So we're going to label those first. My x represents shirts, and my y represents cost. It's important that you label your graph so anyone looking at it can easily see what you're talking about. The next thing is you'll notice we only have about 10 squares on each side, but our numbers go up to 20 and 120. So it's not going to fit. So we need to use something that's called a scale. A scale tells us how we're going to number the sides. When you're choosing a scale, you want to think about 2 main factors. The first is that all the numbers must fit on the graph. The second is that most of the graph should be used. What I mean by that is you don't want your graph to just take up this bottom corner. Your graph should cover most of the area that you have provided. So what we're going to look at is, what numbers do we actually need to show on this graph? Well, for the x values, it goes up to 20. I think that this is about 10 squares. So I'm going to try numbering by 2's and see if I have enough room to go up to 20. So I'm going to go 2, 4, 6, 8. And I do actually have enough room. And then this corner is 0. Sorry, I should have labeled that at the beginning. For our cost, it needs to go all the way up to 120. We already saw if we went by 2's, we only make it to 24. So we probably don't now have enough room for that. I'm going to go by 10s. So I'm going to label it 10, 20, 30. It's important that you label the axes so that anyone looking at your graph knows what numbers you're talking about. We're talking about the cost in dollars and the number of shirts. Now we're ready to graph. So when our shirts are 0, the cost is 20. I'm going to put a dot to represent this first point. Well, when we ordered one shirt, it cost $25. Since we chose to label by 2's, 1 would be in between 0 and 2, and 25 would be between 20 and 30. So we're going to do the best we can to find where those numbers are. 2 would be at 30. 3 is at 35. 4 shirts is $40. 5 shirts is $45. Then we skip and we go to 10. So on the shirts, I'm going to go to 10 and then up to 70. Then we need to go over to 20 and up to 120. So now we have a dot representing each of the points on our table. Our last step is to draw a line to connect the points. Our line tells us that even though these are the numbers that we chose for the number of shirts, we could have chosen different numbers. We could have chosen 16 shirts, and that would have cost $100. We could have chosen 14 shirts, and that would cost $90. And this would show all of the values and all of the numbers of shirts that you could order. We also have an arrow on the end because we could order more than 20 shirts, but that was the biggest number we had, so that's what we showed on our graph. Thank you for watching. I hope this helped. I believe in you. Have a good day.